Hello students, let me once again welcome you back to the fourth unit of the Master Answer 1 course, which is involving the discussion on the methods of distillation. So let us go briefly through the topics learned in the last class. So we have been in the process of understanding the different special distillation methods. So we already have completed the three important special distillation techniques, the steam distillation, and the azeotropic and extractive distillation, which we discussed in the last class with their principle and applications. So also we compared the azeotropic and extractive distillation to see their relative merits and demerits. So in today's class, I am taking up the low pressure distillation technique, so which are meant for separating heat sensitive materials. So what is the importance of low pressure distillation that we'll discuss in the first part of our discussion, and later on we'll discuss one method called molecular distillation, so one type of low pressure distillation, and we'll understand its principle and also the construction and the operation of the molecular distillation apparatus, so that we are taking up in the later part of our session, and also we'll understand its various applications. So what is a low pressure distillation? So many organic substances are very sensitive to heat, that they cannot be heated even to temperatures that are approaching their normal boiling points. Okay. So, if such a thing happens, then the substances will undergo chemical decomposition. Means they get chemically degraded when they are heated up to their boiling points at the prevailing pressure. So, that is a drawback with the organic substances that are naturally occurring one, usually which are found in medicines, food products, and such kind of products. So if such substances are separated by distillation, then you have to see that the distillation is carried out at a very low pressure, thereby can keep the vaporization temperature at a very low level. So if you carry out the distillation in that way at a very low pressure, then you can see that these substances can be separated in pure form without any thermal degradation of their structure. So that is where the distillation to be carried out at low pressure plays an important role in the separation of these important organic materials. So also we should take care that the time of exposure of the substances to the distillation temperature must be kept low. So in order to see that the extent of thermal degradation or thermal decomposition is kept at as a lower value as possible. So that is how we can separate the organic substances using a low pressure distillation technique called the vacuum distillation technique. So let us see where in all this low pressure distillation can be applied. So in cases of like some organic products like vitamins that are extracted from animal and fish oils, and also in the separation of some synthetic industrial products such as plasticizers, are very sensitive to high temperatures. So there, if you carry out the distillation for such kind of products, the temperature must not even exceed a low value of around 300 to 200 to 300 degrees centigrade. So at which their vapor pressure is a very low. So you have to maintain a very low pressure to have the distillation conducted at a very low temperature. So the distillation cannot be carried out in a conventional equipments like or tray column, packed column, or any other suitable equipment, so that we already know. So because in that equipments, maintaining a very low pressure drop would result that very high temperatures are created at the bottom of the columns. That is a concern, and also uh, these conventional equipments will expose the material for a very long time to the prevailing temperatures in the distillation column due to high liquid holdup inside the column. So these are the problems with the ordinary distillation method when you have to separate the products that are highly heat sensitive ones. So we can reduce the pressure, and for that low pressure distillation, we have to have a specially designed apparatus. So such an apparatus we're going to discuss under a distillation method called molecular distillation. So this is one form of distillation which is carried out at a very low pressure uh, in industries at absolute pressures of the order zero point 0.3 to 3 Newton per meter square that is suitable for heat sensitive substances. So let us understand the theory behind the molecular distillation. So the rate at which the evaporation takes place from a liquid surface will be given by an equation called Langmuir equation, which is as follows. So NA represents the rate of evaporation that is taking place, that equals to 1006 Pa into 1 by 2 pi Ma R dash T to the power of zero point 0.5, where this R dash in the equation is gas constant. Okay, Pa is the vapor pressure. So at ordinary pressures, the rate of vaporization is, however, very much less than this because the evaporated molecules are reflected back to the liquid after collisions occurring in the vapor. So, whenever you're vaporizing the given liquid at ordinary pressures, the net rate of evaporation that is taking place from the surface will be much less than that given by the Langmuir equation. So that is because the evaporated molecules uh, will collide with the other molecules in the vapor and will be reflected back to the liquid surface. So the rate of evaporation in that way gets reduced in at the ordinary pressures. Now we can make this better by reducing the absolute pressures to the values used in molecular distillation, that is of the order of zero point 0.3 to 3 Newton per meter square. The mean free path of the molecules become very large of the order of 1 centimeter. So mean free path of the molecules is the distance um, that a molecule can travel in vapor phase, so without any collision. So if that distance is increased, then the vapor will not collide and be reflected back to the liquid portion. So in that way, we can expect the vapor molecule to travel up to certain distance and condense. So and in that way, we can have the rate of evaporation from the surface equal to the that given by Langmuir equation. So if the condensing surface is placed at a distance from the vaporizing liquid surface not exceeding a few centimeters, very few molecules will return to the liquid and the net rate of evaporation of each component of a binary mixture will approach that given by the equation. So that is what we can expect by reducing the pressures and carrying out the evaporation. So if a surface where the vapor molecules can condense are placed at a very close distance from the evaporating surface, then very few molecules can return to the liquid and the net rate of evaporation for each component in the binary mixture will become almost equal to that given by equation number 1, that is Langmuir equation. So the vapor composition or the composition of the distillate now will be different from that given by the ordinary equilibrium vaporization, and the ratio of constituents in the distillate will approach the equation as shown by equation number 2. So this is improved kind of vaporization under reduced pressure. So that is what is used in a molecular distillation technique to get the vaporization done by operating at a very low pressure. So if this ratio is to be maintained, however, the surface of the liquid must be rapidly renewed, since otherwise the ratio of the constituents in the surface will change as evaporation proceeds. So if the rate of molecule vaporization is to be kept at this ratio, then we should that the surface of the liquid from which the vaporization is occurring must be rapidly renewed. Means the surface should be s- changed as should be renewed. That is a change. Otherwise, the ratio of the constituents in the surface will change as the evaporation proceeds. The vigorous agitation or boiling that is present during the ordinary distillations is absent under the collisions of conditions of molecular distillation, and in most devices the liquid is caused to flow in a thin film over the solid surface, thus continually renewing the surface, but at the same time maintaining low liquid hold up. So renewing the surface means uh, removing the surface very frequently from the uh, distillation sur- uh, area. That is, if you make the liquid to flow as a thin film over a surface, then the surface of the liquid keeps getting renewed rapidly, that is continuously, um, at a faster rate. So, in that way, exposure of the liquid surface to the distillation temperature can be kept at a minimum. So, that also helps in the maintaining the low liquid hold up. So, also the rate of evaporation must be kept at the required level by changing the surface of the liquid continuously at a rapid rate. So, if these things are taken care of, then we can expect the rate of evaporation in the molecular distillation at a taking place at a faster rate. Okay, so as I already told you initially, the ordinary distillation equipments are not suitable to carry out um, the low pressure distillation. So what we are using is a specially designed vessel for a molecular distillation operation. So figure shows such a device, so which is used in industries for accomplishing the molecular distillation. The liquid free from gas will be distilled by introducing continuously to the bottom of the inner surface of the rotor, a rotating conical shaped surface. So this apparatus mainly consists of a conical shaped rotor. So this is a rotating rotor. Okay. The liquid that is to be subjected to molecular distillation will be removed of any dissolved gas, and then it will be introduced to the bottom surface of the rotor that is rotating during the operation. The rotor may be as large as 1.5 meter in diameter uh, on the top and may be revolving at a speed of 400 to 500 revolutions per minute. So, the diameter of the rotor at the top may be around 1.5 meters, and the revolving speed of the rotor so usually will be around 400 to 500 rpm. So, a thin layer of liquid to be distilled of around zero point 0.5 to zero point 0.1 millimeter thickness then spreads over the inner surface and travels rapidly to the upper periphery under the action of centrifugal force. So as the rotor is rotating at high speed, as the liquid when it is introduced to the bottom at this point, then spreads along the inner surface as a thin layer, that thin layer rapidly moving in the upward direction due to the action of centrifugal force. Heat is supplied to the liquid through the rotor by radiant electric heaters, and vaporized material is condensed upon a water cooled lower shaped condenser. See, the liquid film, as it passes up as a thin layer over the inner surface of the rotor, so below the rotor there is a radiant electric heater So this supplies the heat through the rotor to the liquid that is flowing as a thin film. So due to that heating, the vaporization from the surface of the liquid takes place and the vapor produced will then be condensed on a lower shaped condenser kept at a small distance from the surface of the liquid phase. So that is how we can get the distillation done in a molecular distillation apparatus. So the operation will be maintained at a temperature sufficiently low to prevent the re-operation and reflection of the vaporized molecules. So this is how that care is taken here to see that the molecules once they are evaporated, they are condensed as soon as they are formed, and to prevent the re-evaporation of such condensed molecule, the temperatures are sufficiently kept low and the residue liquid is caught in a collection gutter at the top of the rotor and the distillate is drained from the collection troughs on the condenser. See, this is how the distillate will be collected on the collection troughs on the condenser. So, and the residual liquid, that is unvaporized liquid film that is coming out from the upper periphery of the rotating bowl will be caught in this gutter. So, from there it can be withdrawn as the residue. Okay. So, this is where the distillate product is getting collected, and through these troughs it can be taken out of the apparatus. So each product is formed from the still body, which is evacuated to low pressure necessary for molecular distillation, and the time of residence of the substance in the still may be as low as 1 second or less. So you can see that um, a reduced pressure is maintained by connecting the outlet pipe here to a vacuum pump. So and the liquid is staying inside the vessel for a very short time of around less than 1 second. So that is how the liquid surface is continually renewed in order to see that no thermal degradation of the liquid take place because of exposure of the distillation temperature for a long time. So such a device is capable of handling 5 into 10 raised to minus 5 to 25 to into 10 raised to minus 5 meter cube per second of liquid to be distilled and gives a separation of 80 to 95% that can be indicated by equation number 2. So the rate ratio of rate of evaporation as indicated by equation number 2 can be maintained in this apparatus, so which can handle a certain quantity of liquid as given here. So you can operate with a 5 into 10 to the power of minus 5 to 25 into 10 to the power of minus 5 meter cube per second of liquid. So this is the flow rate of liquid that we can handle in the apparatus, and it gives a separation of around 80 to 95% in a ratio indicated by the equation number 2. So that is all about the molecular distillation. So in today's class, we initially understood what is low pressure distillation, what is the significance of low pressure distillation, and we studied what is molecular distillation and what are the principles involved in the molecular distillation, and also we learned the construction and operation of the equipment used for molecular distillation. So let us go through the multiple choice questions to analyze how far we have understood the topics. So, molecular distillation is high temperature distillation for heat sensitive material, a very low pressure distillation, both B and C. So I hope you have got already the right answer. So molecular distillation is a low pressure distillation carried out to separate the heat sensitive materials. So both B and C is the option for this question. So which type of distillation is known as evaporative distillation? Flash distillation, simple distillation, molecular distillation, fractional distillation. So evaporative distillation is another name for molecular distillation. So option C is the answer for this question. So if a substance decomposes when heated to its boiling point, the suitable method of distillation is simple distillation, fractional distillation, vacuum distillation, flash distillation. So for heat sensitive product, we have to carry out a vacuum distillation in order to prevent its decomposition. So C is the right answer for this question. The rate at which evaporation takes place from a liquid surface is given by, is it Langmuir equation? Is it Penske's equation? Is it Freundlich equation? Is it none of the above? So in molecular distillation, we learned that the rate of evaporation that can take place from a liquid surface is always given by Langmuir equation. So by reducing the absolute pressure to values used in molecular distillation, the dash of the molecules become very large. So what is the main reason for reducing the pressure to a very low value in the molecular distillation technique? So energy content, sorry, the order of appearance of the options uh, did not take place properly here. So the four options for this is energy content, mean free path, both A and B, neither A and B. So in molecular distillation, the absolute pressure values are used at a very low value. So in order to increase the mean free path of the molecules. So by that we can get the evaporation of the molecules at very low pressure and also have a condensation of that molecule without getting that reflected back to the liquid surface. So mean free path is the right answer. So thank you once again. So for listening to the discussions. So let us again meet in the next session. So in which we are taking up the construction and working of the tray columns and packed columns that are used for distillation operation.